this is a great visual that you guys are all looking at, and I guess we can start from the very top. Let's start from the sun. So the sun hits the solar panels. Those solar panels are generating DC power. That power then goes into an inverter. If we're following that yellow dotted line, the electricity is going into the inverter, and then that inverter creates AC power that can be used at the house. So immediately, once the solar panels generate the electricity and that electricity gets converted to AC power, that electricity wants to immediately service any of your home's electric needs. So your refrigerator's on, any lights that are on, it wants to service your home's electric needs right away. Now, if there's excess electricity being generated, typically without a battery, that excess electricity would actually go back out to the grid, and you would be selling the power to the grid. But with a battery system, if you have one, that excess electricity can get stored into the battery. So once that battery is at a full charge, the last resort for that excess electricity, where it would go is it would go back out to the grid, and you'd be net metering your solar power, and you'd be selling your power to the grid just like you normally were going to do. So that's what happens during the daytime. And at night, when the solar panels aren't generating any power at night, what will happen is, instead of first pulling power from the grid, you would actually start pulling power from the battery. And you would continue to pull power from that battery until that battery gets discharged, at which point then you would start pulling power from the grid. So having a solar system that's grid tied, that also has the integration of a battery system, will actually allow you to function kind of like an off-grid system with the very backup of using the grid if you need to. And what I'm talking about right now is self-consumption. One of those functionalities of the battery that Jane mentioned was self-consuming the power. And that process I just outlined and it illustrated was doing just that, is self-consuming more of the solar power that's being generated. And it's extremely beneficial to do this, because here in New Hampshire, when solar customers net meter and sell their power to the grid, they are selling their power to the utility at a slightly lower cost than the cost in which they have to buy electricity back from the utility. So if you can store the excess electricity in the battery and use it later, keep that electricity on site and keep it local, you, the customer, will actually be seeing a higher value for the solar power because you're self-consuming it and you're not selling as much back out to the grid. So I think that's a really key benefit of having a battery, is not only obviously having it as a backup for power outages, but using that battery on a daily basis when you are grid connected and using it for self-consumption has a lot of benefits.